Guys, I'm sorry this is taking so long. I did not intend to blabber on about this forever. And I'm gonna try and speed this up because I know you guys don't have all night to figure this out. But hopefully breaking up into smaller videos will make it easier for you guys to find things and to understand things and then, process things before we move on to a new topic. So, remember I said the definition of, or the formula for a limit of the tangent line. I'm sorry. Let me start over. The formula for the derivative, and we'll say f prime of x, or the derivative of f of x, is equals the limit as the change in x approaches 0. And you may have seen the letter h. Like, what the heck? Where does h come in? Well, h is just the same thing as delta x. It's gonna be nicer to use. It's just nicer to use h because when you have the big long formula, seeing the letter the letters x and delta x everywhere gets confusing. And so for us visually minded people, h is our saving grace. That h is just it's just a substitute for delta x. So you don't have to look at a bunch of x's and things that aren't really x's but look like x's because there's a delta sign next to them. So I'm going to do this limit as, instead of saying delta x approaches 0, I'm going to say as h approaches 0. So the limit as h approaches 0, or the change in x, the infinitesimally small change of the slope of this line. And remember we're converting this slope format into the derivative formula. So I'm going to actually start with the denominator here. And that's simply a change in x. And it doesn't, and that's h. So that's, I'm actually going to use two versions of the formula, one with the letter h and one with delta x. So let's do delta x over here, and then over here we'll do it with h. Limit as h approaches 0 of a big function there. Okay, so there's your change in x, which is the same thing as saying x2 minus x1, and that's how you can think of it. And then you have y2 minus y1, and I'm gonna, like I said, I'm gonna start with h so you guys don't get confused. But we have h over here, and then we have the function of x plus h. And this is just a really mathematical way to say the new x, or x2, or the new y, I'm sorry. I have to go feed my son, hold on. Actually, it's not quite time to feed him yet. I just paused the video and went to check on him, give him his passy, lay him back down, but he started crying again, so I turned the monitor down, so you may hear a little faint crying in the background. Just know that's what that is. So okay, so back to this function here. This is just another way of saying y2. So it's, hold on a second. Yeah, y2. So you put a minus symbol here, and you say minus f of x. So this is y1. And why is that y2? Well, if you look up here, there's x1, comma y1, and there's x2, comma y2. So you're saying the function, so if y equals f of x, right? That's another way of saying y, but this is saying y is the function. The value of y, so f of x is the value of y at x. And so if f of x is y1, then f of x plus whatever distance traveled is y2. So that's what that means, is the y value at the new x, at x2. You could, another way you could think of this is f of x 2 minus f of x1. Isn't that nice? Much easier than saying f of x plus h. That's all that's saying. x2 is x plus h, because we're going to call this up here, we're going to call this h to make our lives easier. So that distance right there, the run, is what we're getting out of here. So this value here, the value of x here, plus this distance will get us the value of x here or here. It's the same because x, there's a line there. So that's basically what it is, and our limit's finished. So just remember, when you look at this and it looks like really complicated, it's actually not so complicated. It's really simple. Once you understand the concept of a derivative, what it is, how to find it, what in the world is talking about, and you know about tangent lines and secant lines and the slope of those lines as they intersect a function at 2 or 1 given points, then this formula becomes something that's not so confusing, and it's actually rather simple. So I'm going to put the notation with delta x over here for those who aren't having a problem with visual clutter, but we have here x plus delta x, which is just saying x plus the change in x, or x plus the distance traveled. So the first x, you could say x1 plus delta x, and x1 will always be our point here. Oh, I noticed an error. I said up here that this was x1. So now we're going to shift gears a little bit. Now we're going to be thinking of this point, the point that we're looking at, as x1. Because why do we need 3 points? We only need 2. So we're going to find the slope of this line, and infinitesimally smaller as you get closer and closer to 0. So so that don't get confused when I say x of 1. Well, what about this point down here? But it's not. This x1 in this formula refers to the point we're looking at, 3, 3. And so that is simply y2 minus f of x, f of x1, which is y1, and y2 minus y1 is the change in x, so, or the change in y, sorry. And so there's your formula. It looks really, really complicated, especially if you don't like math like me, but it's not actually that complicated. And I'm going to go over some examples on how to use this formula in the next video.